Hey, good morning from my basement wood shop. Hey, what I want to show you today is my Boeing surplus Shoda spindle moulder, a woodworking machine. But I believe that Boeing used it for plastics, like nylon type plastics like that can be machined. And it had, the earliest evidence was plastics. Then somebody bought this thing at a Boeing surplus sale and used it for woodworking. And I believe that they had basically severe lubrication failures on their part, probably. And they cooked the bearings in it, and then they put non-precision automotive bearings in it, and they didn't last because the RPMs and the stresses were too much, and one of them spun and caused severe damage to a shaft like that does. And this thing takes grade 7 spherical bearings, which is kind of different for me. Spherical bearings only machines are generally used in woodworking, and they come in many grades. So Barden will make grade 9, and I found grade 7s, and the standard would be a grade 5. But what was in it was a Japanese brand, Nachi, or one of those grade 7s. So that was an expensive thing to deal with, but accurate bearing, which is well known in the woodworkers, was able to size me up some bearings made in Sweden or Switzerland that are just excellent for a fraction of the cost of the usual suspects, and it's working out just fine. I can talk about that a little bit later. But this is the machine here, the Shoda spindle moulder, and it's thought to be somewhere maybe late 60s, early 70s. Shoda USA doesn't know. Shoda's known for CNC multi-spindle routers used in heavy wood fabrication industry. So it's called, they call this type of machine a spindle moulder in Europe, and over here in the United States it'd be called a wood shaper. Now this one has a feature that I've only found in my research exactly like this, that has traveling overhead support. Now, some of the heavy American shapers would have an overhead support that bolts to the table. Well, this support travels with the spindle. Like the American version, if you moved anything, you have to reset the head. Hang in there, Chloe. And I'll get her some treat or something and she'll be quiet. Now, normally, putting saw blades in wood shapers is not a very good idea. But I did a demonstration of this, and I'll show you how I do it safely, okay? And I'm going to tear this down and show the parts that I made, and you'll better able to see just how this machine is. I borrowed these two flanges here off my tool and cutter grinder. This is an 1.25 inch shaft here, or arbor. Let's start looking at it down here. This is a very unusual machine. Now down here, is the spindle unit, and it unbolts. It's oil circulating. This is a heavy industrial machine. This machine weighs 2,000 pounds and is 10 horsepower. It's serious. got this vented spindle housing for cooling. And I think this is where the previous owner had problems. I'm running the proper oil, you know, keeping up on it and watching it. And if you don't, you can cook something like this. The top speed is 12,500. I got it running at 8,500 right now. So if you're running at 12,500, it's big bearings and stuff in there, you're going to have to change the oil often because it's going to break down. So, okay, here, and it's driven from a motor back here, 10 horsepower. Now, I'm going to get around the side here. Now, this is where this machine gets really strange, and I hope it's not too hard to see. Now I'm going to open the access door here, and I think you can see in there, there's the motor, 10 horsepower, and I've got the original link belts on there, the ones with the metal rivets. It actually came with those, and I tried other quality V-belts, and if you're running really fast, 8,500 and 12,500, this is the way to go. It just runs glass smooth, has all the powers, just no problem whatsoever. And it's got a 3-groove pulley here where on the lower speed, 4,500, you'd run 3 V-belts, and I have that set up. To change speeds, you have to change that pulley. And it's just like a hub on a surface grinder, a tool and cutter grinder. You use a puller that I had to fabricate. They were sticking jaw pullers on these pulleys and damaging them. And that's the least of it. It was a lot of work to fix this. So here's the motor. Here's the spindle. Now, the motor and the spindle are connected to a block that goes up and down with this hand wheel here. Let me unlock it. See here. Now I got a 4-inch travel indicator there so I can set the height in thousands. So the motor and the spindle are connected together and travel together and mounted to a common block. Now this overhead support is mounted to the same block. So once you get this set, it stays set and you can adjust this anywhere. The arbor, 1.25 inch diameter, non-changeable. Okay, I'm going to tear this thing down and you can see it. I'll show you the parts that I had to make. Okay, I think I got everything in the photo here. Something like that, maybe. You can see everything. Okay, I got this piece of plywood mounted in the spindle. It's a German design, but myself, with the availability of what's in the local scrap yards, came up with this alternative. And it's a cam locking device that holds wood, keeps your hands safely away from the cutter, which is right there. And I'm going to start it up and I'll make this cut. And I'll explain further about all of this and other segments, I'm sure. Here we go. Okay. The wood's in the vertical position. And I'm going to run it through. Now I'm going to put it in the horizontal position. And one of the benefits of this is you can push down hard and hold boards flat. And I've had that problem with tenoning sleds. Hard to hold the wood flat. So with this, you can push down on it, and I'll give it a shot. We'll see if we can make a clean cut. I might have to dink around with it. Got just enough room. Okay, here it goes. And there it is. That's a 1/4 inch precision sawed piece. Kind of a funky piece of plywood. But see, that could be snake wood, it could be ebony, it could be the African bloodwood. I can make within plus or minus on hardwood 1/1000 of an inch, easily 2/1000 on dimension sawing. Okay. My wife, she really likes me doing this woodworking. She's never really liked the metalworking, you know, with the sharp chips and the oil and all that stuff. And so it's kind of nice to do this and make things for my wife. It makes her real happy and stuff, you know. That's kind of nice. They just get along. I tell you, my wife, you know, she's a playful girl. And it's like she likes to play tag, but you know, she never lets me drive the car. I'm always out there running. Okay, let's have a look at this here, and I'll try to explain these things. Okay, now I did that little demonstration of doing the most simple cut of sawing a little piece of wood out of this here. And what this device does, it holds the wood down and it captures it. And you can try to cut something like this. This is something like those boxes I've shown. And you can see voids and things. This is that same walnut. And I've had this wood explode. And what I can do is put wood like this, even mounted in plywood if I have to, and then use that device, and I can saw pieces out of it, or I can notch it. Or cut shapes in. And because the device holds it down. Okay? Now, I'll move that and show this. The span blade. That's what they call this thing. They have a short one called the Contorex, Aigner Contorex. And I think that's the only one available in the US, and it's shorter than this. And the longer ones, I've got another one over here, 30 inches long, and this one is 15. So with this and blocks of wood and stuff, you always want to, if you're cutting that highly figured stuff, you would put like wood on both sides of the cut to keep blowout, you know, to keep it from splintering out. So when the cutter's leaving highly figured wood, it's going into some straight grain wood that's not going to splinter. Okay, now with this thing you can put fixtures in, and that's what this is here. This isn't another fixture for sawing, but it's for sawing. I made it specifically for ebony because I got a bunch of thin cut ebony and I can make inlay with it. And I can attach other things. And so this like fits in here, locks in usually like that. Use that mallet to kind of tap it down is the best thing to do. And see, then you got a fixture that's stuck in there. and your hands are still, no matter what cutters you got in there, are on this side. There's some other safety precautions you have to take with this. I won't get into everything, but these machines are actually quite dangerous, like table saws, and some people think they're even worse. Now, if things went wrong, you could have something in this. This is 10 horsepower, and if the machine grabbed it, it would sling this thing clear across the basement here. So you really got to be careful. And the way Aigner, the designer of this stuff that I'm copying, you'd want a safety stop, like at the end of the wing here on the right side of the machine, because you're feeding from the right side to the left. Okay, that's kind of how it works there. Now let's have a look at some of the stuff I've done. Now, this works for me. Now, this is a lock miter joint. I should drag that cutter out because I'm going to put it in. And it cuts this. But if you use this, you can also cut that and mate it. And I've got something here. Let me get that real quick. Oh, sort of junk, too much junk on it. Maybe you can see this. Yeah, right there you can see the dark wood. See that? Now if you look at the side, not a good match there, but it didn't really matter to me. But like right here, look at this. If you're looking at this edge here, and you roll it over and look to that, it looks like a solid piece of wood. Pretty much, okay? Yeah, unless you get into the radically different color. But that joint there is extremely strong, and you can make very strong hollow table legs that out of board. Okay. So with that, okay. Now, for extra safety and less splintering, you make what they call a zero clearance insert. And I do that with these, I use that lock miter for that. Like this blade here, here's a zero clearance insert, and the blade would poke through that. Or you can put a blank piece of wood in, lock it up. See, are you seeing all this? Let me see if you can see the entire top. They loosen these things, and you can move this by hand and push that blade through there. You can center it with this and all that. So I had to make all this hardware because all it was holding together was bolts. And so I had to make all these handles. I had to make this adjuster knobs, had some broken plastic on there. I made these brackets for Harbor Freight dial indicators, which is really cool. You can adjust this thing. Now this is a made in Japan industrial machine, and this is just a great fence. It's just like, it's easy to adjust in thousands. So I can bring that right back to zero. And it's really strong. It's just solid. Okay. I will come back from the other side and start tearing it down. Okay, we'll go from this angle here. First thing I gotta do is make sure that the fence here is open as far, get that out of there. And I don't know if I can get that out yet, but this has to go. We'll give it a shot. One of the things that's missing is a cast iron part of this that kind of rises up, and that is not available. There's virtually nothing available for this but some small parts in Japan. So this is kind of a cool thing for the machinist, you know. Nothing available. You're on your own. You got to fix it. Okay, let's sit down and get out of there. Well, let's set these over here. Yeah, I had to make those. And I was going to notch them like these back here, but I just hadn't gotten around to it. And I go, you know what? They don't catch sawdust. I kind of like it as is. It's just an aluminum handle with good steel insert thread in there. And I've got a bunch of them on a side panel there. I actually made those on a hard-inch chucker. Okay. So I got to that point. Now, it's kind of like a horizontal milling machine. You want to leave the arbor support in place and then break that arbor nut loose, so you're not putting stress on the arbor. And I got to get down here. One of this stuff's not a very fast process. And here's the lock. There's a spindle lock. And of course I had to fix that. It was busted off. Okay, I think I got it. And you gotta remember to remove it. It's not a very big pin. It's a powerful machine. Okay, let's see if I can bust that loose. Yeah. Okay. We're at a good spot there. Now this comes loose here, the overhead support. Oh, wrong place. That's an adjustment that has to be made though. And what I did, it didn't have this, is, let's see if I can get it up. There it is. I had to make a collar here. Now, the spindle here, or the support, is held here, and you can adjust it like that way. And you have to scrape it or shim it to get it exactly this way. Let me pick that up and move it around. It's too heavy to lift up all the way. But what this contains is a spring-loaded cartridge that has a pair of angular contact bearings with a tapered socket that fits this, and this was damaged. So I had to repair this entire thing. The spindle is 26 inches long. That's with the bearings and everything. So the spring-loaded situation here, there's a mark on the little spindle of it, like a band, and I put this collar here, machine this collar at the right spot. Okay, you can screw this support out right there, but you have to run this at all times because you'll get an oscillation, harmonic vibration from having that much arbor sticking out from a cutter. So this has to be on all the time, and that means you can't use cutters that you have to approach or go over center. Made all these parts. There was a couple of spacers there, maybe the nasty looking ones were there. Now these are nice here. I made these for the tool and cutter grinder for cutoff wheels, flanges. I never could find anyone that sold those, but gotta make your own sometime. that is one of those little battery hand saws, and I punched it out on the milling machine to 1.25 inches after precision locating it so it's not running out funky. You can't find that at Home Depot. You have to make it. Make it happen. Okay. They just keep coming off. Okay. Chloe, hold on. Hey, I'll be right back. Yeah, I went all out on this. All these nice handles. I mean, all this stuff is even clocked exactly the way I want it. So you can move that back, lock it, fence locks, all exactly where I want them. That's the fun thing about making your own stuff, isn't it? So, the table rings. Now, my table rings are of many colors because each one is a piece of scrap metal. Now, a set of table rings is unavailable to exactly fit this machine, so you'd have to buy a set. And it seems like Felder, one of the German outfits, I saw some listed. It was like several years ago, over $400 for the set of rings. And I'll show you how they work. I'll knock one out here if I get my hand in there. I'm not going to be able to. Hold on. I got to drop the spindle down for that. And down it goes. I might be able to hook onto it. Let me try to hook onto it with something here. I usually have an O-ring pick or something here. Here we are. O-ring pick. Genuine snap-on pink one. I think I can get that out of there. Otherwise, I'll have to stick my hand. I'll pull the whole mess out. They're probably kind of stuck together. Let's get them out. Look at it. I made all of these on a worn out Monarch 10EE lathe. This brass one here was a giant bushing, or a remnant from making one. And these other ones, see, pop out. They're all tight fitting. See what that is? And here's the spindle. I mean, it comes all the way up, and you can stack up to a 7.5 inch stack of cutters. So you see how these rings fit together? They're tight. This one will pop out too. Then I got some customs. So you can set this like this. Put it back in. This had one with it. It was aluminum and large, and for whatever cutter they were using. So you can take this cutter here and have it down in there. I believe I got a sleeve exactly for this. That'll let it go below the table. But it prevents kind of stuff from getting hung up more, and also helps with chip evacuation, to kind of have this closed off instead of having this small cutter spinning in a big space. And the machine kind of naturally works real good for dust evacuation. So you want to do everything you can to help that, and that's what these rings do. And plus, you know, I think probably would help with splintering or getting crap stuck in there. And of course I got the dial indicators and all this mounts and stuff that I made for this thing. But I thought you might enjoy looking at this. So I want to stick that lock miter cutter back in there and start dinking around with that. And that's the point that I got cancer, and I really didn't go a whole lot further with that, but I am going to do it now. But anyway, this is a machinist playing around with woodworking stuff. Okay. One more thing. Would you fish these antique arm type drafting machines out of a dumpster? I couldn't help myself. Enough of that woodworking stuff. I'm back onto the radial drill. Next episode.